is that it doesn't really look trig-like. So what I mean by trig-like is when we think trig, we think, oh, we want to have something that has a sine or a cosine or a tangent, like any of these things, right? This is what makes stuff trig. Having a sine, a cosine, a tangent, a secant, a cotangent, all of that. And right now, we don't have that. Right now, we have x squared plus y squared equals 1. Okay, but if we think a little bit back to what we learned, a while ago, right? Think of the circle. So if I go to my coordinate right here, so if I go right here to this coordinate, right, we know that, well, I don't like that, sorry. It's too big. So if we go to this coordinate right here, we know that we have another way to say x and another way to say y, right? So even though this equation says x squared and y squared, from the coordinate, we know that we can also write this equation another way. So again, I refer back to the circle and I say, if I think of the unit circle, what does x I probably shouldn't have done that. If I think of the unit circle, what does x represent on the circle? And hopefully you're thinking, oh, x corresponds to cosine. And then if I asked you the same question and I said, oh, what part of the unit circle corresponds to y? Hopefully you're saying, oh, sine. So really, if we wanted to make this more trig-like, we could say cosine squared plus sine squared equals 1. Okay, so I'm hoping that the flow was a little smooth for that, but if not, come to office hours or ask me. But that is probably the main new trig identity. So again, comes directly from this, x squared plus y squared equals 1. But we said, okay, another name for x is cosine, another name for y is sine, and that led us to that, okay? Now here's the good news. The good news is all the other, so notice I put there's 3 flavors. So flavor 1, we just derived together. There's flavor 2 and flavor 3, or form. So I'm going to show you how we can get those. Okay, so the good news is if you know form 1, you can quickly convert it to form 2 and form 3. So let me show you how. Okay, so let's say we have cosine squared x plus sine squared x equals 1, right? Well, if we want to do a quick transformation, we can always say, okay, let me take this and let me divide each piece of it by cosine. Okay, and this is where a lot of these other identities are going to come in real handy. So let me get rid of, dang it, I think if I erase that, I'm going to get, okay, yeah, I'm not going to risk it because so far I think my lecture has been all right. Okay, so what I want to do is I want to focus our attention over here, and I want to ask you I meant to do that. So I want to focus our attention over here, and I want to ask you, is there a more simple way to say cosine squared divided by cosine squared? Now, hopefully in your head, you're thinking, oh, except for 0, right? Whenever I divide something by itself, I'm really just making a big number 1. And you might remember last semester, I really struggled to make 1s. But that ends up being 1. Okay? Now, we do the same thing with the second piece. So let me get a nice little image here. So let's do this like purplish color. So if I look at this purple piece and I say, what's a nicer way of saying sine squared x divided by cosine squared x? So now hopefully you're thinking, hey, that kind of looks like let me see if I could that kind of looks like, here, I haven't really used brown. That looks a lot like the Drake meme, right? See how it says sine squared divided by cosine squared? And this one is sine divided by cosine. So another way of saying sine squared divided by cosine squared, well, what's sine divided by cosine by itself? that's tangent, right? So another way of saying sine squared divided by cosine squared is tangent squared. So it follows directly from this identity if I put squares, right? So hopefully that makes sense. And then over here, now I'm like, okay, I need another way, a simpler way of saying 1 over cosine squared x. Well, now you're like, hey, up here, I learned an identity that said if I divide something 1 divided by cosine, that's another way of saying secant. So this is just secant squared x. And that is your second trig identity. I mean, your second Pythagorean identity. Sorry, it kind of looks ugly. So again, all I did was take the sine squared divided by the cosine squared and simplified. So cosine divided by cosine is 1. Sine squared divided by cosine squared is tangent squared from the quotient identity. And then 1 divided by cosine squared is the secant squared because of the reciprocal identity. So the reason I like teaching the Pythagorean identities together with these other ones is because they all flow from each other. Once you know 2 of them, then you can derive 4 or 5 or 6 or all these others. And then we can do form 3. So form 3 is, again, we're going to start with the original. And we're going to do the exact same thing. We're just going to change what we divide by in the beginning. So if you notice, let me see if I can point this out to you. At the very beginning, let me choose a color we haven't done. So at the very beginning, if you notice, we took the original and we divided everything. See right here? We divided everything by cosine squared. So that's what we did here. Now I'm like, okay, I already used cosine squared to derive one of the identities. So what's the other option? Well, I already used cosine, so the logical option would be try it with sine squared. So now I'm going to divide everything by sine squared. And then we play the exact same game. Can we simplify? So I'm going to go back to this, and I'm going to say, okay, is there a more simplified way of saying cosine squared divided by sine squared? So look at our other identities. And hopefully you see if I can make it super obvious. Hopefully you see this cosine squared divided by, cosine divided by sine looks just like that, right? The only difference is it has The only difference is it has squares, right? So what's another way of saying cosine squared divided by sine squared? Well, that's going to be cotangent squared x. Okay. Then we go to the second option again. I'm going to try to keep the same color scheme. So this one hopefully is a little more straightforward. What's a nicer way or simplified way of saying sine squared x divided by sine squared x? Well, when we divide anything by itself, except the one exception is 0, hopefully you can see that that simplifies to the value 1. Right? So that'll be cotangent squared x plus 1. And then we're going to do the very last part. Do we have a simplified way of saying 1 over sine squared? So again, we look at our list and we're like, okay, do we see 1 over sine anywhere? 1 over sine, 1 over sine, 1 over sine. And you're like, hey, here it is, 1 over sine, right here. So what's another way to say 1 over sine? Cosecant x. So, except it's squared. Notice it's squared. So if we put squared here, we put squared here. So this would be cosecant squared x. And that would give us our last of the 3 Pythagorean identities. Okay, so again, I know that was kind of a lot to take in. I know that I filled in all the spaces and everything, but let me just do a quick recap. Let's see. So I'm just gonna get rid of everything. So I know it's all beautiful, but it'll all be there in on the video, so you can see everything. Wait, why are things not going away? Oh, things are going away. Okay, it's kind of cool. I wish there was a faster way though, getting rid of everything. Okay, so the reason I wanted to get rid of everything was just to make sure that you understood what you had to do or what you're expected to know without notes. So, okay, so I walked you through the derivation of all of them. Now, I want you to know which, let's see, there's 6, 7, 8, 9, 10, 11. So, which 11 identities are you responsible for knowing? Okay, so first one, you need to know, and hopefully you already know, that sine is just a flipped cosecant. You need to know that cosine is just a flipped secant. You need to know tangent is just a flipped cotangent. You need to know cosecant is just a flipped sine. You need to know secant is just a flipped cosine. And you need to know cotangent is just a flipped tangent. Okay, so those 6 I'm hoping very, very straightforward. I know we've talked at length about who's related to who, and you've used, you know, the reciprocal identities before, just not for the purpose of solving. So now we're going to use them to solve. Okay, the quotient identities. You need to know the main one. Well, I wouldn't call it the main one, but the more popular one that we've used, which is another way to say tangent is sine divided by cosine. And you also need to know that if you were to flip that, meaning you get, just like expected up here, you get cotangent x is cosine x over sine x. Okay, so you flip it, you get cotangent. And then lastly, the new ones that we just covered, you need to know the main one. So this is the main one. Sine squared plus cosine squared x equals 1. The other ones are important. Like I know there's 3 flavors of the Pythagorean identities, but this one is like crucial. This one comes up all the time. Like the other ones are important, but this one is like super important. Okay. Again, if you do the derivation, you can figure out that you could divide everything by sine, and you would get 1 plus, divide everything by sine squared, and you would get 1 plus cotangent squared x equals cosecant squared x. Okay, so that's another, again, important, but if you know the one in purple right here, if you know this one, I'll star it. Star. If you know that one, then you can figure this one out. And then the last one, if you divide everything by cosine, you would get tangent squared plus 1 equals secant squared x. Okay. There you go. So that's, again, just to recap, that would bring our total to 1 trig identity, 2 trig identities, 3 trig identities, 4 trig identities, 5, 6, 7, 8, 9, 10, 11. And there are others. There are probably, I don't know, 20, maybe 30 trig identities, so you're probably a third of the way there. There's actually a ton, but these I would say are like crucial for solving.